Okay, welcome back to lesson 7. We are talking about acceleration. So at this point, we would have talked about positions, which is D with an arrow. We have talked about distance, and we have talked about displacement. And then we move on and talk about velocity. Okay, velocity and speed. Velocity is displacement over time. And to get displacement, sometimes you have to do the final positions minus the initial positions, and the directions matters. And speed is total distance divided by time. Today we're moving on to a new quantity. I don't know if you've seen this before. It's called acceleration. The symbol we use for acceleration is A with an arrow. Acceleration is a vector quantities. And what acceleration means is the rate of change in speed. You can translate that into equation. The rates mean how long it takes, right? Like if something has a fast rate, it takes less time. Okay, and the change in speed is change in speed. Okay, and sometimes people can say velocity depending if they accounted for the arrow. Okay, so the equation is this one. Acceleration is delta V over delta T. And they're not being careful here. Can you please add the equation mark? Okay, anything that is changing, it is the final minus the initial. So another way to write this is A is V2 minus V1 over delta T. So this is the way that I would use this equation. Okay, and then there's 4 unknowns, and we're going to talk about how to rearrange it in a minute. And the unit for acceleration is meters per second square, and we usually talk about uniform acceleration. What it means is it's a constant acceleration. Okay, so questions for you. It tells you a car increases the speed by 10. That is your change in speed, right? How much did the speed change? It changed by 10 meters per second in 5 seconds. What variable with 5 seconds? What is the car's? They're asking you to calculate what is the car's acceleration. So A is what they're looking for. The equation for A, if we go back to this, I have delta V and T. So I would be using this equation here. So acceleration is delta V over delta T. So I can sub it right in. So it's 10 meters per second divided by 5 seconds. So 10 divided by 5 is 2. And the unit we already talked about. A lot of you will just say it's meters because it looks like S is at the top and S is at the bottom, and you cancel it. You are not allowed to cancel it. This one is meters per second square, and I'm going to explain to you why. Okay, so we're going to go back to math. I know some of you don't like math, but I need you to understand acceleration is not, because some of you are going to go in and and cancel it. You can't do that. Okay, let's undo this. Meters per second divided by second. Do you understand that? That's what this means, right? So meters per second, when I'm dividing by second, it's the same thing as multiplying the reciprocal. I'm only allowed to cancel if I'm multiplying and one is at the top, one is at the bottom. But do you see both are at the bottom now? So meters times 1 is meters, second times second is second square, and that's why the unit is 2 meters per second square. A woman is out for a jog and is walking at 1.5 meters per second north. It takes 3 seconds to accelerate to a sprint at 7.5 meters per second. What is her average acceleration? Okay, so they give you 1.5. That is when she started. So this is actually the V1. What the speed she started off with? 1.5 meters per second north. It takes her 3 seconds. Things that are measured in seconds is your time. To accelerate to 7.5. That's another speed. What speed is it that they're talking about now? V2, final speed. What is her average acceleration? So acceleration equals to question mark the equation for acceleration is delta v over delta t. But I don't have delta v, but I can calculate it by just taking the second one and minusing the first one. So I'm going to do it on the side and then plug it in the equation. So v2 is 7.5 minus v1 is 1.5. So 5 meters per second. No, sorry, lies. 6. Do you math? 6 meters per second. Now I can throw this into here now because I've found out what is the change in velocity. It went from 1.5 to 7.5, so the change in 6. So now I can use 6 meters per second divided by the time, which is 3 seconds. So 6 divided by 3, that gives me 2. What's the unit for acceleration? What is it? Yes, 2 meters per second. Okay, so sometimes it does require you to do it 2 steps. Then some of you are going to ask, am I allowed to do it in 1 step? Totally. But you have to write your equation out correctly. Because if you go back to the no, remember how we have this one that's in yellow? Like we can use this one too, right? So if you want to do that, I'm just going to do it quickly to show you. You are allowed to totally do it all together in 1 step, but you have to write your equation out correctly. Okay, so 7.5 minus 1.5 divided by t. So you still, it's the exact same thing, right? 7.5 minus 1.5. So that's my 6. And divided by 3, I still get 2. So this is if you do it in 1 step. And this is if you do it in 2 steps. And both ways are fine. Okay, truck is traveling at 20 meters per second east when it applies brake. So it's slowing down. After 5 seconds, it slows to 5 meters per second east. What is the truck's average acceleration? Okay, we didn't really talk about it, but if you have an acceleration that is negative, meaning it's slowing down, does it make sense that the answer here, I should be getting a negative? Okay, so I'm just going to write down, if acceleration is negative, it means that it's slowing down. All right, so given I started off, that means my V1 is 20. And then it took 5 seconds, that is my T. And then it slowed to, meaning the new speed, V2 is 5 meters per second to the east. What is the acceleration? Equation for acceleration is change in V over change in T. To find change in V is V2 minus V1. Okay, V2 is 5, V1 is 20. 5 minus 20, negative 15 meters per second. Then I'm going to put it into this equation. Now I've found delta V, so meaning negative 15 meters per second divided by the time, which is 5. Negative 15 divided by 5. Negative 3 meters per second square. I left the seconds here. Meters per second square. My acceleration is still that. East or west? Whatever the direction is, that is the direction we write down in the answer. Okay? So now we're moving on to graphs. We're still talking about velocity time graph. We already talked about velocity time graph. Okay? And this is like a sequence. Hopefully this is to help you remember. We have already done position time graph. That was the first graph that we found. And with a position time graph, it looks like this, right? D with the time. And then we said that if we ever find the slope, we found the velocity. And that's what this is, okay? They want you to remember that if I take the slope of position time graph, it gives me velocity. And today, this is the new one. Today, if I'm teaching this to you, if you find the slope of a velocity time graph, it represents acceleration. So the velocity time graph, if I calculate the slope, I get acceleration. And so they give you a VT graph. velocity time graph, they would like you to calculate acceleration. So on a test, I'm not going to remind you what you have to do, right? So I would suggest you draw this picture down to remind yourself, like these are the clues. I make sure I remember that. So I need to find the slope. So that means you have to find the slope. Okay, and you know how to find the slope. We've done it numerous times. Okay, but this time I'm writing A. Okay, acceleration is what I'm finding, and I need to calculate the slope. Slope is y2 minus y1 over x2 minus x1. So you pick 2 points. They already picked for you. Okay, this point is 0, 0. This point up here is 5 and 20. You read from the graph, right? 5 and 20. Okay, so y2 is 20 minus y1, which is 0, over x2 minus x1, 20 divided by 5, 4 meters per second square to the right. Okay, remember, unit for acceleration is meters per second square. Get used to the units. Okay, if you need to do a chart and summarize it all for yourself. Okay, that is when I have one slope. How about if I have multiple slope? Then you would have to break it into multiple sections, just like we did. Okay, so I'm going to block it up into 3 chunks. Call them A, B, C. So the question tells you the cheetah is the fastest land animal. It reached the speed of 30 meters per second, but it can only maintain the speed for short spurts. They would like you to calculate acceleration from a velocity time graph. So I know I'm hinting you need to find the slope. So you're going to remember, if I want to calculate acceleration from velocity time graph, I have to find the slope. That is a knowledge that you're required to retain on the quiz or a test. Okay, so it's like okay, I do know this one. I can now calculate it. Okay, separate the 3 sections. For part A, for part A, I'm going to find the slope, which is the A. And the slope that I'm going to be using is y2 minus y1 over x2 minus x1. Pick 2 points along A. That looks like a good point. Anyone. I'm going to pick this one. I know I always pick the end. I'm going to pick that one. Okay, this is 0, 0. This is 4 and 20. The slope is y2, which is 20, minus y1, which is 0, divided by x2, which is 4, minus 0. 20 minus 4. 20 divided by 4, that is my 5 meters per second square, and the direction is forward. Part B, when I have a velocity that keeps on going at 30, right? It stays at 30 meters per second. I'm not asking you, what is the acceleration? How much are you speeding up? When you keep driving at 30, your acceleration is 0. So there's no calculation involved. Does it make sense reasonably? Acceleration is how much are you speeding up, how quickly. But if you didn't even speed up at all, you stay at the 30 meters per second, you didn't speed up. Okay? Finally, part C, pick 2 points. Let's pick this point right here and this point right here. So the first point is 8 seconds. 30 meters per second, and then this last point is 10 seconds at 0. Okay, acceleration is y2 minus y1 divided by x2 minus x1. y2, remember which one is 1 and 2? I think I still have people who's confused about that. This is your 1 and this is your 2. The earlier time is your 1 and the later time is your 2. Okay, this should work out to be a negative slope. I'm slowing down, right? So let's see if it's negative. So y2 is 0 minus y1, which is 30, divided by x2, which is 10, minus x1, which is x. So 0 minus 30 is negative 30. 10 minus 8 is 2. I got the answer to be negative 15 meters per second square for